So let's look at this question. This is what we brought this question up yesterday. What's the interval of convergence for this series? Now, what do you want to do? You want to take this thing and just build an H chart and write out the first couple terms. So it says, okay, N0. Starting at 0, going to infinity. So what's the first term going to be? Huh? 0. Why? Because it's 0 times the numerator. And anything to the 0 power is 1. So you have 0 times 1, and 0 in the numerator gives you 0. 0, so the sum is 0. Yes? Next term, put a 1 in there for n. What would you get? You would get 2x, take away 5, over 3. So that would be your sum. 0 plus 2x, take away 5 over 3. If you don't do this, right, it's not helping you answer the, well, it is helping you answer the question. It's helping you conceptualize what's being asked. So now what? You want the interval convergence. We're going to pause this. This is a non-calculator question, so you would get 2 minutes. Because why? Correct. Here it is. Here's the work right here. What he's saying is exactly right. See, I can pull this n and n plus 2 out here. What's happening that gets really, really large? You L'Hopital. It's giving you 1 over 1. You're only concerned about this. 2x plus a negative 5 caret n. That's got to be less than 1. So from negative 1 to 1, when you drop the absolute value symbol, add 5 across inequality, divide by 2. You get 2 to 3. Now, what we're going to do today takes this, goes beyond this. It's like 2 to 3, yes, that's the work. And then what about specifically at 2 and 3? And that's a big deal, but we're not there yet. So correct. The answer is A. So this is copied and pasted from the alpha lesson. P series test, where P is the exponent. It'll converge if the exponent is bigger than 1. If the exponent is 1, it diverges. And if the exponent is less than 1, then it's certainly going to diverge because the value of n is in the denominator. So that would make the denominator smaller, which makes the fraction larger. So we're going to go back to absolute and conditional convergence. If the series converges absolutely, if the absolute value, ready? If the absolute value converges absolutely, means the absolute value converges, then the series converges. Converse error. You can't exchange what's in front of if with what's in front of then. If the series converges, then it converges absolutely as a converse error. Okay? If the series converges, then it converges absolutely. But if it converges absolutely, that's telling the absolute value converges. So example 4. In example 4, here's the harmonic. 1 over n. 1 over 1 plus 1 over 2 plus 1 over 3. When you build that H chart, the column, the middle column is getting smaller. But the fact that the middle column is getting smaller does not guaranteed converges. And in fact, the harmonic diverges. But the alternating harmonic converges. If the signs alternate in the harmonic, then it will converge. So you're going to problem 23. I'm going to pause this, and you go to 23, please. So when I come back to this, what this means. If the series converges absolutely, then the series converges. The converse are, you can't exchange with what's in front of if with what's in front of them. So think about this. If we talk about the alternating harmonic, that converges. But it doesn't converge absolutely. Because if you take the absolute value of that, it doesn't converge. So the example that this refers to would be alternating harmonic. That's the converse error. If it converges, that doesn't mean that it converges absolutely. Number 23. So what have I got here? Well, the terms are alternating. You've got 1 plus n over n squared. Well, we haven't done this. But if I go to sequential mode and graph it, I just type it in here. And it spits out the terms. Ready? The first term says begin at n equals 1. So n equals 1, you have negative 1 squared, so it's going to be a positive term. And you have 2 over 1, so you have a 2. And then these are the terms, and then we plot them. So at n, you're up to 2. And n's 1. At 2, you're down to negative 3/4. At 3, you're at 4/9. That's where this is going. And you see how this is going. It's converging, because these terms are alternating above the x-axis, and they're getting closer and closer to the x-axis. Yes? So this thing is doing what? It's converging conditionally. Why? Because the only reason this is converging is because the signs are alternating. And if you took the absolute value of this thing, you have n over n squared. If you L'Hopital that, you get 1 over n. So the limit is it's going to the harmonic. And the harmonic diverges. So this thing converges conditionally, meaning it only converges because the signs alternate. Now what? Well, what is the error after 99 terms? Well, after 99 terms, the error is going to be less than the 100th term. Think about that. See, what's the error after the second? It's easier to look at it, the second term. After the second term, right? The second term we're here. So what's the sum? 2 plus a negative 3/4 is 1 1/4. But then what happens? This bumps up to 4/9. Everything after that is reducing the 4/9. See, because this number is going to be, the next number is going to be negative and work against the 4/9. And the number after that's going to be positive, but it's going to be less than the number just worked against, then worked against it. So the number's got to be, error after 2 terms has to be less than 4/9. So the error after 99 terms has to be less than 100 term. So I just put 100 in here. 100 in the expansion, and got this decimal 101/10,000ths. So the truncation error after 99 terms has to be less than the absolute value of 101/10,000ths. Way more user-friendly than LeBron. Okay. So, how about this example? I've got the cosine of n over n squared. And I put these terms in there. So what's happening? The numerator is just going back and forth between -1 and 1. The denominator is n squared. So what is this? This is a P series where P is greater than 1. It's going to converge. Okay? It's going to converge. And then this one, alternating. It's -1 to the n plus 1 over n. So this converges conditionally. Because if we didn't have these signs alternating, then I would compare it to the harmonic. And the harmonic, but you have to understand this. You have to understand this expansion up here, from the beginning of the chapter, and you have to understand that harmonic diverges and the alternating harmonic converges. So, right here, the only direct comparison you're accountable for, remember the direct comparison test works for only non-negative terms. And the only one you're really accountable for, it's not geometric, it's e to the x. But the ratio test is your ticket to success. Now, 6D, this is where we're getting to what's on the AP test. So this is example 6D in your book. So we want to know, what is the interval convergence for this? Okay, and then, let me see how that's written there. Six D is just what's on the left. And then all right, so what's on the PDF is this. Here is the ratio test for 6D. So what do? We took this expression and we replaced the n with an n plus 1. Then we divide the next term by the term we have, we invert and multiply, and that's how we get this right here, which we load the tau, which gives us x take away 3. So I skipped this step on the PDF, but you can see it in the textbook. So we go back here. This is what we get after applying the ratio test. So the interval convergence, the absolute value of x plus a -3 has to be between -1 and 1. We drop, we solve the inequality, add a 3 across, we get 2 to 4. Yes. But now we got to test the endpoints, meaning, are they open or closed at the endpoints? So we literally go to the question and put the endpoint in there. 2. What do you get? 2 plus a -3, because 2 is your x. 2 plus a -3, caret n over 2n. Which is what? It's -1 caret n over 2n, which is a size change of 1/2 to the alternating harmonic, so it converges on that endpoint. we put 4 in there, 4 in the question, and you get 1 over 2n, which is the size change of 1/2 to the harmonic. It doesn't matter. The harmonic diverges, half of it's still going to diverge. So the interval looks like this. Bracket at -2, parentheses at 4. It converges absolutely. 2 to 4 exclusive of the endpoints. But when you include the endpoint, 2 to 4, 2's included and 4's excluded. So here's what happened. If I put those numbers in here, the first 3 terms, -1/2, 1/4, -1/6. The 2, that's converging. 1/2, 1/4, 1/6 is diverging. Okay? So, if it is not geometric, if it's geometric, that's what you're looking at. Summary test of the endpoints. If it's not, you factor out the harmonic. So we're going to show you what this looks like on an AP test. And yes, you can expect to see this. So if I go to 2011B, and again, ready? Did it happen after that? I'm only looking at the questions before the anticipated FRQ document. So you have your own set of questions post 2012 after. So I go back here, 2011. We don't need to solve the whole question. We just need to look at what they're going to expect you to do. 2011B. Question 6 will be from chapter 9. And it tells you this. Ready? The radius of convergence for the Maclaurin series is 1. Determine the interval. That doesn't sound too hard, right? If it's Maclaurin, then it means it's definitely centered at 0. Maclaurin is a subset of Taylor. So we would have centered at 0. So we go -1 to 1. And at -1, look what they're getting. They're all negatives. It's the opposite of the harmonic. At +1, this is the alternating harmonic, which converges. So the answer on the scoring guide is -1 is less than x, which is less than or equal to 1. It's just another way of writing parentheses, -1, comma 1 bracket. Okay, with that thing right there for B. Two points, I think you should get more than 2 points in that. It's 2 out of 9 right there for analyzing the endpoints. So when you get the interval, it's what's going to happen every time. You're comparing the endpoints to the harmonic, or the alternating harmonic. If it matches up, the signs are alternating the endpoint, it converges there. And if they're not alternating, then it diverges for that component of the question. So